In the name of God. Hello, dear students. Welcome to Ferho's website. My name is Masoud. I'm a physics teacher. I'm gonna, let's say, solve practice 1D, page 12 for you in this lesson. Let's get started with question number 1. Let me read the question for you. It says, number 1, a remote controlled car's wheel accelerates at 22.4 rad per second squared. So what's this? This is the acceleration, angular acceleration actually, angular acceleration. Let's say I recognize it by its unit. Even if you, let's say, because it doesn't mention angular acceleration. It says a car's wheel accelerates, right? It doesn't mention angular acceleration, but you can, let's say, recognize it by means of its unit because it has a second square. If the wheel begins, look here, begins with an angular speed of this one. Begins means initial, so we have, let's say, initial angular speed. What's the wheel's angular speed after exactly 3 full turns? So what's unknown here? What's the wheel's angular speed after? What does it mean? So we look for omega f. After what? After exactly 3 full turns. I told you turn means cycle, right? Revolution. So 3 full turns means we have delta theta, which is equal to 3 rev. Yeah, 3 revs, 3 revolutions. Let me read, let's say, answer this one, erase this one. So delta theta is equal to 3 revolutions. I summarized it actually for you. Let me, so we look for what? We look for omega f. This equation is solved actually by one of the 4 kinematic equations in rotational motion. I want you to focus on these equations. They are very important, right? And I told you in previous lessons that if you have a problem with memorizing these rules, you can, let's say, you can use the let's say linear equations that we got it in grade 11 and compare them with one another. That's why it will be easy for you for memorizing the new equations, right? Because they are, I told you, they are, let's say, twin. Rotational equations are twins for what? They are rotational twins for linear kinematic equations. So anyway, I summarized the given and unknown. We have alpha, we have omega I, means initial angular speed. We look for final, let's say, omega. We have delta theta, but delta theta is given in rev. You have to convert it into the rad. How do you convert it? Just by multiplying by 2. I told you whenever you observe rev without thinking, just, let's say, substitute rev with 2 pi, and is equal to 6 pi rad. So, what do you have in mind right now? Yeah, guess the equation. Guess the kinematic equation. Which equation is valid? We don't have delta t here, so you have to look for an equation without time interval, and only one equation, let's say, exists in among the 4 equations. Only one equation, let's say, does not involve delta t. This equation, omega f squared is equal to initial, let's say, angular speed squared plus 2 alpha delta theta. Just substitute the values, right? So omega f, we look for omega f because it's unknown, right? Omega I, 10.8 squared plus 2 alpha. Do we have alpha, right? Yeah, we have alpha, 22.4 multiplied by delta theta. Are we allowed to write 3? No, because it's given in rev. You have to convert it to rad. How do you convert it to rad? By let's say, multiplying by 2 pi, and you have to write 6 pi in place of delta theta. And after that, you square this term, and you have to multiply these, let's say, values together, and after that, add them up together to get the one number. Is this number the last answer? No, because we have this Vx square. You have to take a square root of this equation. So put it under the radical. Omega f is equal to radical 960.64. And the answer is approximately 31 in which unit? In rad per second. This is the, let's say, first equation, first question for practice 1D. Let's move on to question number 2. How long? If it says how long, means, let's say, we look for what? We look for delta t. We look for, the, let's say, time interval. How long does the wheel in term 1 in item 1? So it's related to the item 1. It has to do with the question number 1. How long does it take the wheel in item 1? Let's say to make the 3 turns. So it mentions, actually, it mentioned 3 turns. We knew these, let's say, information. Even we added one new information, which is omega f. We found omega f already. That's why maybe there are more than one way to solve the equation, but we look for a simple equation. So we look for delta t. I summarize the essential information here. We look for delta t. Alpha is available. Initial omega is given. Omega f, we found omega f already. Actually, which equation is valid? This equation, maybe you say, teacher, what's this equation? Is it new equation? No, it's rearranging of one of the 4 kinematic equations, right? Guess which equation actually rearranged to take this form. Let me write the equation for you. Omega f is equal to omega I plus alpha delta t. So the origin of this equation is this one, right? Let me, let's say, prove it for you. I want you to bring this this value here. Omega I, let's say, turn it to the left side, it becomes negative. So omega f will be omega f minus omega I is equal to alpha delta t. Right now, I want you to rearrange the equation for delta t. Anything that multiplies the variable goes down. What do I mean by this? It means alpha goes down like this, and the other term goes to the numerator. So delta t is equal to omega f minus omega I over alpha. So it's not a new rule, it's just a let's say, rearranging of one of the kinematic equations. Do we need any, let's say, conversion? No, because all of the dimensions are, let's say, are unified. We don't have any, we don't need any conversion. Omega final, 31, minus omega initial, 20, let's say, 10.8, right, divided by alpha, 22.4. So firstly, you have to, let's say, subtract 10.8 from 31. You get the number divided by 22.4 to find the answer. And the answer is given in second because, let's say, the equation, let's say, is devised for delta t, right? You look for delta. Let's move on to another question. Question number. Yeah, so we done. Thank you very much for for watching this video, and bye for now.